So in this video, we'll discuss how to use the t-distribution table, which is table C in your textbook. Now, in the previous chapter, which is chapter 14, every time we did an inference technique, then the table that we used was the Z distribution table. Now here, if you're going to use a T procedure, then what we're going to use is the T distribution table to find T star for a confidence interval and the p-value for a hypothesis test. Now first let's just look at the table. We have degrees of freedom in the first column. Look at the first row. It gives all the confidence levels starting from 50% to 99.5, 99.9%. Now suppose we're looking at a sample of sample size, let's say 11. Then the degrees of freedom is 1 less than the sample size. So it's 11 minus 1, which is equal to 10. So the 10th row is the t-distribution for, so the entire row is the t-distribution for degrees of freedom 10. Now suppose I'm trying to find a confidence interval using a Z procedure, and let's say the confidence level is 95%. And we're using the T procedures. Then instead of a Z star, we'd be looking for a T star. And this is exactly how you do it. So you're looking at table 10 and you're looking at the column headed by 95% confidence level. Go down this column, go up this row, and the number that you see here is 2.228. That is the T star for a confidence level of 95% in a T procedure with degrees of freedom 10. Now let's look at one more example. Suppose the sample size is, let's say, 26, which means degrees of freedom is equal to 25. And we're looking at a confidence level of 90%, and we need to find T star for a confidence level of 90%. So let's look at first the row headed by 25. So we're looking at this, the row headed by 25, and the column headed by 90%. So we go down the column until we hit the 25th row, and then we go across and stop at this point, and that would be the T star for a 90% confidence level. Now if we look at the table, now let's just follow any one column. Okay, so we have the 95% confidence level. So let's start here. Go down this column and notice what's happening to the values of T star. Notice that they're getting smaller and smaller and smaller as the degrees of freedom is increasing, which means as the sample size is increasing, the numbers are getting smaller. But what's important to notice that is that the T star values that are getting smaller are really getting closer and closer to the number 1.960, which is the Z star. And this happens because we've discussed this in the previous video. It happens because as the sample size increases, the t-distribution starts looking more and more like the Z distribution. So the T star values, as the sample size increases, get closer and closer to the Z star value. So we just discussed how to find T star values for a given confidence level. Now the same table can be used in the case of a hypothesis test when we actually get the value of T star and we need to figure out the p-value. So our question is, what is the p-value if T star is given? So let's assume that T star is equal to, let's say, 3.2, and the degrees of freedom is equal to, let's assume it is a 20. Let's say degrees of freedom is 20. So we're looking at the row headed by 20 because that would be the t-distribution for a sample size of 21 or a degrees of freedom 20. Now we know our t star is 3.2 and we need to find the p-values of t star which is equal to 3.2. So we go across this row looking for the number 3.2. Now if you're going and looking for this number in that row headed by 20, we're looking for the number 3.2. Now you'll notice that we obviously will not have all the numbers, we have only a few numbers in that row. However, we found two numbers between which our t-value sits. Our t-value is 3.2. So 3.2 lies between 3.153 and 3.552. So if we are trying to find the p-value of the t-statistic 3.2, we cannot find the exact p-value. However, we go down this row to find the p-values for 3.153. We go down this column to find the p-values related to 3.552, and depending on what we need, whether it's a single-sided p-value or a two-sided p-value, we can find the two p-values for the two t-statistics that we see here between which 3.2 lies. So we can assume that the p-value related to 3.2 lies between the p-values of those two numbers. So for example, if it's a single-sided p-value, then it's going to be 0.001 and 0.0025. So our p-value for 3.2 lies between 0.001, which is the smaller of the two numbers, and 0.0025, which is the larger of the two numbers.